To conclude this chapter and this semester, let's take a look at an application of integrals. Application of integrals basically being the area between two curves. Suppose we have two functions, f of x and g of x, and we want to calculate the area between those two functions. We see that for this we need to know the points of intersection, so we need to know the first point A and the second point B where those functions are crossing. And then the green area basically is the area below f of x minus the area below g of x. And then previously we saw that the area is the integral. So this is actually the integral of f of x dx between boundaries a and b minus the integral of g of x dx between those same boundaries, or the integral from a to b f of x minus g of x dx, where f of x is the upper function. So f of x is the one which is lying on top, g of x is the function lying below. Find, for example, the area which is bounded by y equal cosine of x, y equal to 0, x equal to 0, and x equal to 3 pi over 2. It's always best to first make a sketch of the area so you can see where the functions are lying and which one is the upper function and which one is the lower function. In this case, we see that the area is composed out of two different parts. You have an area A1 from 0 to pi over 2 where cosine is the upper function, and then an area A2 from pi over 2 to 3 pi over 2 where the x-axis is the upper function. So the area that we are looking for is the area A1 plus the area A2. So it's the integral from 0 to pi over 2 of cosine of x minus 0 dx plus the integral of pi over 2 to 3 pi over 2. And then we have 0, so the x-axis is the upper function and the cosine is the lower function. So it is the integral 0 to pi over 2 cosine x dx minus the integral of pi over 2 up to 3 pi over 2 cosine x dx. If we solve this, the integral of a cosine is sine of x, so sine of x between the boundaries 0 and pi over 2 minus sine of x between the boundaries pi over 2 and 3 pi over 2. Then we see that sine of x in pi over 2 is 1, minus the sine of 0 is 0, minus, and then the sine of 3 pi over 2, which is minus 1, minus the sine of pi over 2, which is 1. So in the end, we get an area which is equal to 3. So the red area is equal to 3. Next, let's take a look at the area between the curves y is x squared minus 2x and y is equal to 4 minus x squared. First of all, we will need the points of intersection. So where intersect these two curves? Points of intersection, you just put the curves equal to one another. So x squared minus 2x has to be the same as 4 minus x squared. Or 2x squared minus 2x minus 4 is 0, which means that x squared minus x minus 2 is 0. We can then factorize this. So this is x plus 1 times x minus 2 equal to 0. And so the points of intersection are x equal to minus 1 and x equal to 2. If we then make a sketch of these functions, we see that the function 4 minus x squared is the upper function between these boundaries. Therefore, the area is the integral between the points of intersection, so the integral from minus 1 2, 2 of the upper function, which is 4 minus x squared, minus the lower function, x squared minus 2x dx. So it is the integral minus 1 to 2, 4 plus 2x minus x squared dx, which is equal to 4x plus x squared minus x to the power 3 over 3 between minus 1 and 2. And so if you calculate this, you get that the area is equal to 9 square units. And then finally, find the area between the curves x is y squared minus 12 and y is equal to x. Again, start by making a plot, but what we see here is that it's very difficult to calculate this area. Why? Because you would have to split the area. You see that the tip only composes of the parabola, so the x is y squared minus 12. And then from a certain point on, you have an area between the parabola and the first bisector. Furthermore, this first area is composed of a positive part and a negative part, which means that you have again to split it in two parts. So there is a lot of calculations going on if you want to calculate the area this way. So there is a better way to do this, which is looking at the figure in the y direction instead of in the x direction. So what you will do is take the variable of integration equal to y instead of x. To do this, you basically flip the image that you had, and your y-axis now becomes the x-axis and the x-axis becomes the y-axis. In this case, you see that y equal to x is always on top. So we now have a function x equal to y, which is the upper function all the time, and a function x is y squared minus 12, and then we need the points of intersection, so the points where y is equal to y squared minus 12, or y squared minus y minus 12 is 0, which means that y plus 3 times y minus 4 is 0, so y is minus 3, or y is equal to 4. And then we can calculate the area as the integral, so the integral from minus 3 to 4. The integral now has a variable of integration y, so it is dy, and then the upper function y minus the lower function y squared minus 12. We can calculate this easily, so this is y squared over 2 minus y to the power 3 over 3 plus 12y between boundaries minus 3 and 4. And then some calculations later, you will find that this is equal to 343 divided by 6.